Welcome to our journey through coding history. From punch cards to Python, we'll explore the evolution of coding into today's digital language. Whether you're a seasoned programmer or just curious, let's dive into this fascinating transformation. In 1801, Joseph Marie Jacquard revolutionized weaving with a loom using punch cards, pioneering machine automation. Fast forward to the 1840s, Ada Lovelace, collaborating with Charles Babbage, crafted the first algorithm for his analytical engine. She foresaw machines creating music and art, a vision remarkably ahead of her era. In the 1940s, computers like ENIAC and Colossus emerged, using vacuum tubes and filling entire rooms. Programming them was a complex task involving cables and switches. Alan Turing's groundbreaking work during World War II laid the groundwork for modern computing, despite the challenges of programming these early machines. They were powerful yet cumbersome, setting the stage for the evolution of programming languages in the 1950s. In the 1950s, assembly language emerged, simplifying programming. Grace Hopper developed COBOL, a high-level language closer to human language. Fortran and BASIC made programming accessible to scientists and students, marking a significant leap in coding evolution. The late 70s and 80s introduced personal computers, empowering individuals to code at home. By the 1990s, the internet transformed coding with HTML, JavaScript, and Java, enabling interactive and portable web applications. This era marked a significant shift, making coding more accessible and setting the stage for the collaborative and open source movements that followed. Open source revolutionized coding by enabling global collaboration. Git and GitHub became vital for developers to share and enhance code. Python emerged as a powerful yet beginner-friendly language, now essential in artificial intelligence and web development. These advancements have made programming more accessible, setting the stage for future innovations in technology. Today, coding is central to everything from apps to AI. Tools like ChatGPT are speeding up code writing. The future? Quantum computing, low-code platforms, and even coding with brainwaves. It's an exciting time as we push the boundaries of what's possible in technology. Python's journey began in the late 1980s in the Netherlands. Guido van Rossum, inspired by ABC, crafted Python during a Christmas break in 1989. Named after Monty Python, it was designed for simplicity and flexibility, setting the stage for its future as a versatile and beloved programming language. Python 0.9.0 debuted in 1991, introducing exception handling and modules. By 1994, Python 1.0 was open source, nurturing a vibrant community. Its core philosophy focused on readability, making it accessible and beloved by many. This foundation set the stage for Python's growth into a versatile and widely used language. Python 2.0, released in 2000, introduced garbage collection and list comprehensions, enhancing its capabilities. Web frameworks like Django and Flask emerged, establishing Python as a web development powerhouse. Major companies like Google and YouTube adopted Python, significantly boosting its reputation and solidifying its place in the tech industry. Python 3 launched in 2008, breaking backward compatibility to advance the language. This shift was significant, as it took until 2020 for Python 2 to officially end. Python 3 introduced better Unicode handling and new syntax features, setting the stage for Python's future growth and versatility in various fields. Today, Python is a top choice in data science, automation, and web development. It runs on servers, microcontrollers, and even browsers. Its versatility is a key strength. Python's future is promising with AI-assisted coding tools and a focus on tech education. Guido van Rossum is actively advancing Python at Microsoft. Python continues to be a powerful and cherished language, ensuring its relevance and adaptability in the ever-evolving tech landscape. HTML's journey began in 1989 with Tim Berners-Lee at CERN. By 1993, HTML 1.0 emerged with just 18 tags, enabling basic text formatting and links. As the web's popularity surged in the 90s, HTML evolved, adding more features to meet growing demands. CSS emerged in 1994 to separate style from structure, revolutionizing web design. By 1996, CSS1 allowed styling without cluttering HTML. The real game changer was CSS3, introducing media queries, transitions, and grid layouts, enabling modern responsive web design. This evolution transformed the web, making it visually dynamic and adaptable across devices. JavaScript emerged in 1995, crafted by Brendan Eich in just 10 days. Despite initial browser inconsistencies, it became crucial for web interactivity. Over time, JavaScript evolved with ECMAScript 6, frameworks, and server-side capabilities, transforming it into a versatile powerhouse for modern web development. Thanks for joining this journey through the history of coding. From early machines to modern languages, coding has transformed our world. Keep exploring coding and innovating. Python is incredibly popular and versatile, appealing to both beginners and seasoned developers. This presentation will explore Python's strengths and limitations, providing a balanced overview of its pros and cons. Python's syntax is simple and clean, resembling English. This makes it an excellent choice for beginners. No need to worry about complex syntax like curly braces or semicolons. Python's versatility is unmatched, spanning web development, data science, and more. Libraries like Django and TensorFlow accelerate development, making Python suitable for diverse applications. Its adaptability is a key strength, allowing developers to tackle various projects efficiently. Python's massive global community is a significant advantage. Solutions to common problems are often readily available online thanks to countless forums, tutorials, and open source contributions. This extensive support network is invaluable for both beginners and seasoned developers, ensuring that help is just a search away. Python's cross-platform compatibility is a major advantage. You can write code once and run it on Windows, Mac OS, and Linux with minimal changes. This flexibility is invaluable for developers working across different systems, ensuring seamless integration and deployment. Python excels in rapid prototyping due to its simplicity, allowing quick development of minimum viable products. This makes it a favorite for startups and innovation-driven projects. However, its interpreted nature results in slower performance compared to compiled languages, which may not suit high-performance applications. Python's interpreted nature results in slower performance compared to compiled languages like C or Java. This can be a limitation for high-performance applications, where speed is crucial. While Python excels in many areas, it's not always the best choice when performance is a top priority. Python isn't the top choice for mobile app development. Languages like Kotlin and Swift dominate this space due to their optimized performance and native capabilities. Python's mobile capabilities are limited, making it less suitable for mobile platforms compared to these specialized languages. Python can be memory intensive, posing challenges for resource-constrained devices or large-scale applications. Developers must carefully consider memory usage in their projects. This limitation is crucial when working on systems where memory efficiency is paramount. Python abstracts many low-level details, making it unsuitable for hardware-level programming or embedded systems. Developers needing low-level control might look elsewhere. Compatibility issues between Python 2 and 3 can be problematic. Older libraries may not support Python 3, so developers need to manage version compatibility carefully. Compatibility issues between Python 2 and 3 can be challenging. Many older libraries lack support for Python 3, requiring developers to carefully manage version compatibility. This can complicate projects, especially when integrating legacy code with modern Python applications. Python is excellent for beginners and rapid development. However, it may not be suitable for high performance or low level tasks. Choosing the right tool for the job is crucial.